What will we do here? Well, first of all, we need to balance the reaction. How do we balance this reaction?
We put a 2 in the HCN hasta la derecha.
Okay, I will have a number 2 here, a 2 here, and we already know that the other coefficient will be 1, that I will not write it, but we have 1 molecule or 1 mole of potassium sulfate and 1 mole of sulfuric acid, ¿ok?
Matemática.
Sí.
¿Por qué? ¿Por qué? ¿Falta? 9 por punto 9, no. Por la misma cantidad de 9 me da 100.
I don't know.
No se supone que no te debería dar, te debería dar 9.1 decimal. No debería ser exacto.
I don't know, but let's find out. Okay.
Entonces rompí la ley decimal, ¿o qué?
Okay. Your laptop, please. Now, we have 13 moles of potassium cyanide. That is this one. And they are asking you for grams of the other 3 substances. How many grams of sulfuric acid? Grams of sulfuric acid are needed. And then how many grams of the 2 products are produced? As here, everything is being worked in grams, well, I have at least 3 different procedures to do this. I can do the calculations in moles using the mole ratio, and at the end, use the molar masses. Or I can write the complete reaction in grams, multiplying the molar masses by the number of moles in the balanced reactions, and work everything in grams. These are 2 of the different I think you have at least 3 or 4 different ways to do this. I will transform everything into grams so you can see this way to solve this kind of problems. So to transform it into grams, I need the molar masses. For sulfuric acid, it is 98 grams per mole. Then in potassium cyanide, we have 39 from potassium and 12 carbon and 14 of nitrogen. 65? Okay, we have 39 of 1 potassium. Then 12 carbon and 14, yes, 65. Yes. Then potassium sulfate, sulfate is 96, and we have 2 potassiums, 39 2 times. 174.24. Okay, let's work with round numbers. Okay? So it is 174 grams per mole. And here we have 14 and 12 is 26, 27, yes? These are the molar masses. The molar mass is for 1 mole. I haven't multiplied by the coefficient. Okay? It's the same as potassium cyanide. It is 65, but I have 2 moles. So if I write the balanced reaction in grams for every substance, I will need to multiply all of them by the number of moles in the balanced reaction. That will give me 98 grams. 98 grams of sulfuric acid react with 130 grams of potassium cyanide to produce 174 grams of potassium sulfate and 54 grams, 27 times 2? Is it clear that those numbers come from multiplying the molar masses by the number of moles in the balanced reaction?
Yes.
Pablo Emilio?
Yes.
Yes? Okay. Now I can start working with all the numbers. But first, I need to transform these 13 moles into grams. What was the molar mass for potassium cyanide? 65, yes? So I have 13 moles times 65 grams per mole.
No, you multiply for 1 mole and then you divide by 65 grams.
Excuse me?
You first multiply by 1 mole.
Why? Why should I multiply it by 1 mole?
No pondría lo mismo de cualquier forma, es uno.
Eh?
No pondría los 130 gramos en vez de 5.
What is the mass for 1 mole?
65 grams.
65 grams is 1 mole. If I use the 130, I should put 2 moles below. Yes?
Pero se te haría lo mismo.
Yes. You will get 845 grams of, this is potassium cyanide, yes? See? Jimena?
Yes.
Okay. Now I can start with the 845 grams of potassium cyanide, and I will do the same calculation 3 times with the different, we can call it grams ratios. Instead of mole ratios,
Miss, ya sé qué pasó. El mío viene grams y el tuyo viene moles.
you did not do the correction I told you. It was 13 moles. This is one of the things I changed. Remember that I told you? No, you don't remember, because if you remember, you should change it. But don't worry. If you did it with 13 moles and the procedures are correct, it's okay. Well, now I know the number of grams. I will start with 845 grams of potassium cyanide, and my first conversion factor will have potassium cyanide before. How many grams of potassium cyanide according to the balanced reaction? How many grams of potassium cyanide do I have in the balanced reaction? 130. Yes?
Ay, había por 48 gramos de...
And up and above, I will use the grams of the substance on white I want to calculate. So I will start with 98 grams of sulfuric acid, and then it will give you is 845 times 98 divided by 130.
O sea, arriba siempre pongo el número con el que estoy, digo, con el ácido que estoy trabajando.
Above, you put the number with the units you want in your result. It doesn't matter if it is an acid or whatever else we have.
Pero, o sea, ¿por qué pusiste el 98 y no el 54?
Because I want the grams of sulfuric acid. And 98 grams of sulfuric acid react with 130 grams of potassium cyanide. This is what I use as a conversion factor. Okay? So I have 630 grams of sulfuric acid. See? That's the first answer. A. I am recording the class, so everything you're saying is being recorded here. So please put your feet down.
Santiago.
¿Qué pasó, Oscar?
It's because I don't know. I thought I did the correct.
You did what?
Oh no, perdón.
This is the answer to question B. How many grams of sulfuric acid are needed? Ay, ¿por qué puse 630? Sorry. It is 637. Sorry. This was a mistake for me. 637. Aquí lo tengo en la calculadora, sí.
¿Estos videos para qué los usas?
¿Eh?
¿Estos videos para qué los usas?
For you.
Sí, it's gonna 37 grams of H2.
Yes, of H2SO4. Okay, now, to solve the other amounts,
Lo mismo, pero con...
I will get this again. The same 845 grams of potassium cyanide. And then I will use
Miss, pero cuando empieza la B es lo mismo.
the 100 and...
Esa es la B. Y ahí se acaba.
B is that one. I will start with C.
O sea, pero la C también es de 845 de arriba. Es que la
Why I start with the 845 grams? Because it is the given amount I have as a data.
Ajá, en la B y luego en la C.
It's exactly the same amount. For this amount of potassium cyanide,
You're getting what's
how many grams of potassium sulfate and hydrogen cyanide were produced in this reaction with this amount?
They're different questions.
There are different questions, but the three calculations start with a given amount of potassium cyanide. Okay?
If you put the same values, you're gonna get the same.
I will put the same value here because this is what I need to cancel. Yes?
Yes, and you're gonna get hydrogen cyanide.
Miss, voy al baño.
Yes.
And then you need to change it to get potassium.
And then I will put it here again.
Voy, sí.
It's the same thing. It's 6-1.
Now it's 54 HCN.
So I will write above the equivalence in grams or the grams ratio between potassium cyanide and potassium sulfate. What is the amount I need to write above? What is the stoichiometric amount of potassium sulfate that corresponds to 130 grams of potassium cyanide? 174.
174 K2SO4. Yes.
And then I will do the same with hydrogen cyanide. What is the stoichiometric amount of hydrogen cyanide that is produced by 130 grams of potassium cyanide? 54.
Miss, pero es que no entiendo esa de arriba. O
¿Qué?
sea, ¿por qué pusiste el de hydrogen sulfide? Digo, el sulfide.
¿Eh?
El sulfuro.
¿En cuál?
O sea,
Tienes que parar.
en eso de arriba. O sea, esta.
Ahí, para que
Okay. What is the what they are asking you in question B?
Tienes que apuntar.
Reactant 13 moles of potassium cyanide.
Question B.
Ajá.
How many grams of sulfuric acid?
Que es 65.
How many grams of sulfuric acid are needed to react with 845 grams of potassium cyanide that are 13 moles?
Te tocó.
Pero dice, how many grams of sulfuric acid? Y sulfuric acid
Is H2SO4.
Ok, de eso lo convierto a grams. Ah, no, ya entendí, pero no estoy entendiendo dónde sacaste el 65.
You are not understanding what?
¿De dónde sacaste el 65 gramos?
It's the molar mass.
De
65, no, 65 is the molar mass of potassium cyanide. And then you multiply this by 2 because it's the coefficient in the balance reaction, so you get this 130 grams. Then the molar mass for potassium sulfate is 174 times 1, is what you have here. The molar mass of hydrogen cyanide is 27 grams per mole, multiplied 2 times is the 54 we have here. And then 98 grams per mole of sulfuric acid times 1, that is the coefficient, is what you have here. Yeah? Okay, so how many grams of potassium sulfate?
Wait.
Aquí we cancel this with this, and this with this, and this with this, and we have
1,131. 1,131 grams
okay.
of potassium sulfate.
So we have here 1,131 grams of potassium sulfate. This is the first part of answer of question C. And then we have 845 times 54 divided by 130.
351.
And these are the grams
Grams of hydrogen cyanide.
of hydrogen cyanide.
Yes, ma'am.
Questions?
No, ma'am.
Sure?
Entonces,
Yes.
ahí ese problema, el limiting reaction.
We don't have limiting reactant. When do we have limiting reactant? If they give you amounts, of the two reactants, most of the times, one of them will be the limiting reactant. If they only give you one amount, there's no limiting reactant. They are asking you here for the stoichiometric amount of the other reactant that you need for the reaction to happen completely. There's no limiting reactant here, because they are not giving you the amount of the other reactant. They are asking you to calculate the exact amount that will be required. Yes? ¿Sí?